Can you imagine what the world we live in would be like without light?
No, Mom, I can't.
Why don't we try? Come on, turn off the desk light, the one in the passage, and the one in the fish tank. Oh, and the one on the tablet.
Okay, I don't think we'll be able to do much, but it'll be fun.
We'll hardly be able to see anything at first, because our eyes, you'll be surprised how much we can see without those lights.
I'll lower the blind as well, to shut out the light from the street.
When we discovered fire, our way of life changed dramatically. Up till then, it had been limited to daytime. But now we could live a nocturnal life after dark. People used fire as a source of light and heat, to protect themselves from possible predators, and to cook food. It was perhaps one of humanity's most important discoveries.
రావడం ఆలస్యం కాదు ఎవ్రీడే పాప్
Some animals can see much better than we can in low light conditions. This means they can hunt at night in the dark, when they have hardly any competitors. Their eyes can capture more light. There are also others, like glowworms, that can give off light. They have organs that react with a molecule called luciferin, producing light and heat.
What if we light a candle, like when there's a power cut? Everything really does look different like this. I like it.
Yes, it's like when you read a book. Your imagination can take you wherever you want. The thing is that when there was no artificial light, our ancestors could see the stars much better at night.
In prehistoric times, people already knew the starry sky and the periodic movements that took place in it. Later on, they used them to establish the first calendars, which they linked to their way of life, to hunting, and then to agriculture. Knowing the stars wasn't a hobby to them. It was essential to their survival. For thousands thousands of years, we've called this constellation Orion. In historical times, when these stars appeared in the sky, there were frosts in the northern hemisphere. Winter was coming. With these stars in Leo, the frosts ended and spring began. This was vitally important in agriculture. When summer arrived, they could see these three stars overhead. Together, they formed the summer triangle. We call them Vega, Deneb, and Altair. And in autumn, this big square called Pegasus appeared. This happened and still happens repeatedly year after year, written in the sky. When there were no compasses, or sat-navs, or mobile phones, sailors far out at sea also used the light from the stars to guide them. All night, we see the other stars turn around it. It's the pole star, and it's north. Its light has been a guide for navigating the high seas. You can find it from the plow in the constellation of Ursa Major, the Great Bear, following the direction marked by Merit 170,000 years to cross the first of the sun's layers, where photons are absorbed and scattered by the particles there, beginning a chaotic, almost endless journey which prevents the photon from traveling freely. Once it's got past that layer, it reaches the convection zone, where it's pushed towards the outside by huge columns of gas, until finally, after crossing the photosphere, the chromosphere, and the solar corona, it escapes from the sun. It travels the 150 million kilometers that separate the Earth from the sun in just 8 minutes. But not all photons are able to penetrate the Earth's atmosphere. Many are sent back into space, and others are absorbed by the atmosphere itself. Those that do manage to reach the Earth's surface are vitally important to us.
Why are they so important?
Plants, algae, and some bacteria use the light from the sun to perform photosynthesis. This is tremendously important to life on our planet. They provide us with oxygen, which is essential for breathing.
So this plant produces the oxygen we breathe.
From this chemical reaction, triggered by sunlight, plants and other organisms get the energy they need to live, and also provide food for all the animals, including us.
Of course, like food.
That's right, fruit. Very good. Plants are at the beginning of the food chain. Other living creatures eat them, and that's how we get foods like milk and meat.
This very complex chemical reaction is called the Calvin-Benson cycle. It's one of the most important in nature. It consists of a set of biochemical processes that take place during photosynthesis. The carbon dioxide absorbed through the pores of the leaves reaches the chloroplasts, where the whole cycle is carried out. As a result, glucose is formed, an organic molecule present in all living beings. So to sum up, this cycle makes it possible for inorganic material to be turned into organic material and incorporated into many living beings through their food.
Mom, I understand that we couldn't live without light, and that there would be no life on Earth without it, but
What is it? Tell me.
I'm finding it more and more difficult to understand what light is.
Well now, that's a very, very complicated question. You're quite right to find it confusing. It's taken science a long time to answer that question.
Newton thought that light was made of little particles, but his contemporary Huygens insisted it was a wave. Both theories could explain what was then known about light.
I feel this is real. And from my eyes, yes.
Later, new experiments showed that it must be a wave. But what sort of wave? Because up till that time, all the known waves, such as sound, needed a material medium to propagate. And yet light propagates in a vacuum at 300,000 kilometers a second. Since the second half of the 19th century, thanks to Maxwell, we've known that light is an electromagnetic wave. When that wave comes up against matter, it behaves like a particle in which all its energy is concentrated. That particle is the photon we were talking about. So light is a wave and a particle at the same time. Since the 20th century, thanks to Einstein, we've known that nothing can travel faster than light. Quantum mechanics describes waves and particles as one and the same thing.
Because that is moving.
The energy of each photon depends on the frequency of the wave. In other words, the number of times it oscillates per second. The greater the set of all frequencies is called the electromagnetic spectrum, and it ranges from radio waves, microwaves, which we use for heating food, visible light, ultraviolet light, X-rays, which have enough energy to pass through skin and tissues and show us our bones in radiography, up to gamma rays, which are the most energetic of all and reach us from the universe.
So we can't see all those other kinds of light?
Our eyes only let us see in this small part of the electromagnetic spectrum, which can pass through the Earth's atmosphere and which we call visible light. But with the help of technology, we can get to know the universe by observing other sources of light. Come on, I'll show you. This here is the Grande Can. It's an enormous optical telescope in the Canary Islands. Scientists use it to study the night sky in search of answers to all the mysteries that have yet to be solved.
Light from the whole universe is still traveling to the Earth. Apart from the recently discovered gravitational waves, all the information that reaches us is in the form of light. Human beings have invented all sorts of instruments to detect it. From radio telescopes on the ground to space telescopes capable of seeing infrared light, ultraviolet, and X-rays. So we can see nearby objects, visible to the naked eye, whose light takes just a few seconds to reach the Earth, such as the moon.
Radha, can you sit in the middle?
Some of the planets, which are light minutes away. Or comets, which develop visible tails when they are closest to the sun, providing us with very valuable information about the origins of the solar system. Distant objects, whose light takes many years to reach us, such as young stars, some of them still with the nebulas they were born from. Old stars, at the end of their lives, at the center of the nebula they expelled when they died. And we can look at galaxies like Andromeda, the most distant object we can see with the naked eye, whose light started out over 2 million years ago.
Radha, నేను నా మీద పెట్టుకుంటాను. నువ్వు తీసుకొచ్చి బాగా తీసుకోవచ్చు.
And obtain magnificent images of thousands of galaxies and clusters of galaxies with large telescopes. There are also dark regions in the universe that we can't see, but we can detect them. In these regions, the force of gravitational attraction is so great that not even light can escape. They are black holes. Stellar black holes originate when a large star, much more massive than our Sun, reaches the end of its life and explodes as a supernova. At the center of most galaxies, including the Milky Way, there are supermassive black holes which play an essential role in the formation and evolution of galaxies. If they don't let light escape, how do we detect them? From their gravitational influence on the neighboring stars that we can see. From the radiation emitted by the matter that is being swallowed up by them. And from the enormous deformation of space-time, which deflects the light from other more distant stars. Of light. Over the course of our history, we have managed to tame it. We have gone from using torches to using light in a whole range of things, not just to illuminate a space. We fill our lives with lights which accompany us in everything we build, in the things we investigate, in the search for solutions inspired by nature, in improving our health. We play with it to create works of art, to put on shows, to screen images in films. We are doing so right now, here in the planetarium. And the most exciting thing of all is that it continues to surprise us. We are almost constantly finding new properties and applications of light.
Hey, Mom. Maybe one day I could study something to do with light.
If that's what you'd like, great.
Fireworks are really cool.
An aquarium.
Yes, they're beautiful. But we must be very careful not to misuse them, and light in general.
By doing so, we'll preserve the darkness of our skies, helping to conserve animal and plant biodiversity. We'll save energy and make a big contribution to keeping this planet the way we found it tens of thousands of years ago.